Alrighty, problem number 3. It says given. Sounds like a proof. Once I say given and proof, once I hear that, that's what I'm thinking. Alright, given the vertices of quadrilateral JKLM with those coordinates, okay, they want to prove this is a parallelogram. So, my first step is to sketch, right? Sketch. Well, I'm drawing a parallelogram because that's what they told me, right? That's what I want to prove. And its name is JKLM. To name it, just start with the first letter and pick somewhere on your diagram, and then just go clockwise from there, okay? And yesterday, we learned how to prove quadrilaterals are parallelograms, and we learned 3 methods. This was the 3rd method. And I'm going to focus on it today because it's the shortest. It's the quickest out of the 3 methods that we learned. All right? And what we have to do is show that our diagonals, JL and KM, bisect each other. All right? And the way we'll show it, right? That's our method. The way we're going to show that is to show that each diagonal, right, those 2 diagonals, that they share a midpoint, right? If you can show that the diagonals share a midpoint, that means they bisect each other. And if you can show that this shape, the diagonals bisect each other, well, then you've accomplished that. You have accomplished that JKLM is a parallelogram. So that's the flow of what we're doing. So we have to make 2 calculations. One of them for diagonal JL, we're going to calculate the midpoint, and then we're going to calculate the midpoint of KM and show that they're the same and write up our proof. So let's go ahead and get started. The midpoint of segment JL, that's going to come from 2 calculations. That's going to come from this X and that Y, all right? We are doing J and L, so to get my X's, right, to get the X of my midpoint, I'm going to add up my X's, minus 3 and a 7, minus 3 plus 7 over 2. And to get my Y's, right, to get this thing here, to get my Y midpoint, I got to add up my Y's and divide by 2, the average of my Y's. Okay, when I do the calculations, I'm going to get negative 3 plus 7, that's positive 4 over 2, and then 1 minus 2, that's minus 1 over 2. Well, that simplified is 2 comma minus 0.5. That's the midpoint for the red, for the red segment, right? That's the coordinates of that midpoint. We need to find the coordinates of the blue one now, which will be the same. So the midpoint of segment KM, right? Same idea, using the midpoint formula, except now we're focusing on K and M. K and M. And we want the X's, 1 and 3, 1 plus 3 over 2, and then our Y's, minus 5 and 4, minus 5 plus 4 over 2. Well, when we do the math, we're going to get, well, 1 plus 3 is 4, so that's 4 over 2, and a negative 5 plus 4 is a minus 1 over 2. Look at that. They're identical. We're going to have the same midpoint, 2 comma minus 0.5. Yeah, so it turns out our midpoints are the same. Verifying that, I could just add in this step. The midpoint of JL is equal to the midpoint of KM, right? And then when we write up our proof, we're going to start by restating what they asked us. JKLM is a parallelogram because, right? And then we're going to state the method of proof that we used. Because the diagonals bisect each other. And then it'd be nice to give them a little extra reason how we know they bisect each other. We would just talk about the tool we used and the fact that they share a midpoint. So JKLM is a parallelogram because its diagonals bisect each other, since the diagonals share the midpoint. We're going to say it, 2 comma minus 0.5, and QED. That's just a fancy way to end a proof. Quod erat demonstratum, Latin for what was set out to be demonstrated. Awesome.